Assalamu alaikum and good morning. Greetings from the Department of Software Engineering, Daffodil International University. Hope you all are doing fine by the grace of the Almighty. Thank you all who are joining us in this morning. It is a very special day for us as we have Professor Dr. Muhammad Rizja Wahidin, the Honorable Vice Chancellor of University Saints Islam Malaysia today with us. Professor Dr. Muhammad Rizja Wahidin is the keynote speaker of today's session who will enlighten us with the knowledge of quantum computing, which currently constitutes one of the most promising research areas in today's world. In this regard, I would like to mention that Professor Rizja obtained his PhD from UK in August 1989 on quantum optics. We also have our Dr. Muhammad Imran Hossain, Director Administration, Daffodil International University, Dr. Nadir bin Ali sir, Additional Registrar, Daffodil International University, uh, Dr. Imran Mahmood, Head of the Department of Software Engineering, Daffodil International University, as a special guest. Our our chief guest, Professor Dr. S.M. Mahbubul Haq Mojumdar sir, will join later. Now, I would like to request our department head, Dr. Imran Mahmood sir, to deliver his greetings, welcoming our honorable keynote speaker to start his session. Dr.
Assalamu
Imran
alaikum.
Mahmood.
Assalamu alaikum. Good morning, everyone. Thank you, Nusrat ma'am, and
Wassalam.
welcome our honorable Vice Chancellor of University of Malaysia, Professor Dato Rizal Wahiduddin sir. And it's an honor to bring you here because today the topic, like quantum computing, we don't find many experts in around the world. And when we found you and we found that you are interested you accepted our invitation, we become very happy and we feel honored. And so hopefully today the speech you are going to give on quantum computing, it will enlighten our student about a new part, a new avenue of computer science and software engineering. This is actually Department of Software Engineering. We actually focus on software, but our chairman, who is a visionary man, he told me that we also should focus on quantum computing. It might be a future. So again, thank you very much. Salamat datang ke Bangladesh, and hope you can start. Thank you, Prof.
Thank you.
Prof, you can start your session. Yeah.
Oh, I can start my session. Okay.
Yes, Prof.
All right. Bismillah ar-Rahman ar-Rahim. To Madam Nusrat Jahan, who seems to be playing the role of the MC today. And of course, we have Dr. Imran Mahmood, just introduced me just now, followed by Dr. Muhammad Nadir bin Ali. And the rest of the gentlemen, ladies and gentlemen, fellow participants, students, Assalamu alaikum warahmatullahi wabarakatuh, and a very good morning. So, Alhamdulillah, today I'll be sharing something that is called the quantum advantage, quantum safe, as well as the Kibble Balance. So, the reason I chose this topic instead of just focusing on quantum computing is to let the audience see the bigger picture, I hope. Because a lot of things are happening within the field of quantum physics, quantum information, quantum computing, quantum security. I think it's better for me to give an overview. Perhaps it will open the minds of our participants today to look into it in more detail later. Of course, the first few minutes is the adjustment of my slang, how the Bangladeshi audience will adjust to the Malaysian way of speaking English. So I hope through the few minutes that we go through, this kind of adjustment will be sort of ironed out Is that okay? So far, you can understand what I'm saying? Great. Right, so if I can show my first slide. Right, so this is the title slide. And if you look into the picture, the photo on this slide, that was when I was leading a team in Mimos Berhad. This is a ICT Research Institute, which is a government-owned company, registered as a company. And my team then was looking into quantum cryptography. So from this photo, you can see it's not theoretical, just theoretical. It's a combination of theory as well as the real practical implementation of quantum cryptography. People also call it with associated with quantum key distribution. So that will be, this particular photo will fall under quantum safe, okay, quantum information security. And my stint, I was loaned out, seconded to Mimos Berhad from the year 2005 until 2011. So 6 years there to lead the R&D on cybersecurity for the nation, and focusing especially with the quantum key distribution or quantum cryptography. So the presentation today, as I said earlier, it will be broken up into 3 segments. I'll talk first about quantum advantage, followed by quantum safe, as well as the Kibble balance. For quantum advantage, initially it is called quantum supremacy. But just like human rights, they have some opposition among the scientists and technologists. They don't like the word supremacy. So they changed the word from quantum supremacy to quantum advantage. So from this particular slide, I think you can see there are big players already involved with quantum advantage, specifically in quantum computing. So I would say that it is being led, as far as America is concerned. You have the IBM, you have the Google, Microsoft, as well as the Korean, the Japanese, the British, and so on. Now, a bit of a crash course on what is quantum physics. Now, if we try to see things, how can we be able to see objects? So many, many years ago, there are 2 schools of thought. One, if you see an object, that object will be emanating some kind of light into your eyes. Okay? So the other school of thought is that some light is coming out from your eyes, and therefore it touches on the object you want to see, and therefore you'll be able to see it. So the one that I'm showing right now on the screen, Superman. So you see the light's coming out from the eyes, and it will touch on the object, and therefore vision will be able to be realized, because from this school of thought, by light coming out from your eyes, it will touch on the objects and you'll be able to see. But the other school of thought is light coming from the sun, for example, reflected off the object and enters your eyes. So if the first one is correct, that means if Superman version is correct, then we'll be able to see even in darkness. So this doesn't really happen, because if we are in a room and it is dark, we cannot see objects. So it becomes apparent that the second school of thought, which is if you want to see objects, we need to have light coming from somewhere, from the sun, bounces off the object and then reaches our eyes. So that's how we see things. Now, most of us, including myself, I need help by using glasses, spectacles, for short-sightedness, and some of us for long-sightedness. And sometimes if we want to see something further away, we may have to use the binoculars. Sometimes if we want to see objects up in the sky, we use telescopes. And if we want to see something very small, we need the help of microscopes. So the way things have been created, our eyes will not be able to make enough resolution to see, this kind of objects. Therefore, we need aids in the form, visual aids, in the form that I've just described on this slide. Now, if we look into the spectrum of the electromagnetic radiation, what we call a visible light is just a finite, a small bandwidth of the whole spectrum of the EM field. So there are other things that we cannot see. So some of the movies like The Predator, you cannot imagine these beings able to see beyond the visible light. So in our case, we are restricted, even using the visual aids that I've shown in the previous slide. We can only see things within the constraint of the visible light. So the thing now is, what happens if we even say that we make use of this visible light and we focus this visible light? Let's say we take a laser pointer. Laser pointers, sometimes in red in color, sometimes green in color. What other colors do we have? Maybe beyond the green and red, I do not know. It's quite sophisticated today. But imagine that you dim the intensity of the laser pointer. As you dim it, it becomes less intense, less intense, less intense, and eventually you get nothing. Okay, you can imagine you get nothing from the laser pointer. So this slide I'm sharing with you is saying that if you imagine that we have so-called enclosure or container, and then we remove all the matter in this container, sucking out, okay, all the matter is being removed from this container enclosure, and we cool it down to almost absolute zero. So that, in essence, is what we define as the vacuum, nothingness. Okay, nothingness, vacuum. But the beauty about this is when you remove the so-called matter from this container and you reduce the temperature of this container to zero, almost 0 Kelvin, absolute zero, you would have thought that everything is not there anymore, it's nothingness. But in reality, you still have fluctuations. The electromagnetic radiation is still fluctuating by Allah's will. So this radiation is not theoretical. So if you Google it, you will be able to see it through the internet. Scientists have now verified through experiments that they can sort of real-time observe this vacuum fluctuations. This nothingness is still there. And how to explain these fluctuations, which is supposed to be emptiness? We look to the diagram on the right-hand side of the screen, which I call it the quantum harmonic oscillator. Right? So this basically represents the intensity of the energy of each oscillator. So if you like, the wavy lines that you see on the left-hand side is represented with these energy levels. Each wavy line is associated with a quantum harmonic oscillator. So as you reduce the temperature of the container, you will get the energy approaching n equal to 0. So E0 becomes half h omega. Okay, so at that point, everything is still fluctuating, but the energy is called a special kind of energy, 0-point energy. Right. So what I'm trying to get at is, when we move into the realm of quantum physics, we are dealing with very, very small objects that are governed by quantum mechanics and quantum physics. These are called quantum objects. So at this level, quantum objects, they exhibit wave-particle duality. So you could imagine an electron, for example. Usually we think of it as a matter particle, but in the realm of quantum physics, it also exhibits wave-like characteristics. So you can imagine electrons can also exhibit interference. Okay, so similarly with the light, when you talk about light, when you reduce the intensity of light, they can also exhibit particle behavior. So in this realm, quantum physics realm, we are talking about wave-particle duality. So as a result of this, things become uncertain. And to describe quantum objects, we lose a lot of determinism. We introduce the concept of probabilities. We introduce the concept of uncertainties. So when we introduce this kind of concept, normally ignorance is considered a bad thing. Okay, ignorance, not knowing something, is not considered good. But in information science, we may look at it something as positive. There are 3 levels of ignorance I can share with you. Ignorance number 1 is when you go to the ATM to withdraw some money, you need to have your, for example, your password, and you may have your ATM machine card. Okay, so in this case, you have your password, what you know, and then what you have, which is the card. And sometimes additional security, what you are, biometrics, your thumb. Okay, so this first level of ignorance is good because you do not want somebody else to know your password, to get hold of your ATM card, and not to have your thumbprint or even your iris, the eyeballs here. These are biometric kind of thing, which is personal to the individual. So at this first level of ignorance, it is good so that it safeguards. Okay, it safeguards your information so that somebody evil may not be able to get information or money from your bank account. The second level of ignorance beyond this is where you have random numbers. Okay, so random numbers are also introduced so that, a lot of things can be secured. By introducing random numbers, when you want to communicate with something or someone with a computer, your random numbers will be able to also sort of put an extra layer of communication. For those who are playing games, of course, random numbers are very important. Online game, by introducing this randomness. And if you go into detail, randomness, random number generator may be generated mathematically, but if it is generated mathematically, the chances are it will repeat after a few cycles. So people are looking for the truly random number generator. So again, quantum physics give you the opportunity to get such things. And the third level of ignorance we are talking about is beyond this, the first two, and it's about something that Allah has made it such way, God has made it such way, no matter what you try to do, there's nothing wrong with the measuring device. You just simply cannot pinpoint. For example, if you're looking at an electron, you cannot simultaneously know its position and speed or velocity simultaneously. So you lose determinism you can only talk about in terms of probabilities or uncertainties. So in quantum physics, we relate this to the Heisenberg uncertainty principle. Now, let's put this concept into some ideas so that we become clearer when we move from classical information or conventional way of dealing with information and then migrating to the quantum information. From the traditional classical experiment, if we have 100 classical 1-bit memory locations, and if we prepare all these 100 1-bit memory with the same value, okay, for binary digits, we have only the option 0 or 1. Okay, so imagine in this experiment, this thought experiment, we prepare this 100 class one that we measure, okay, will reveal, for example, the value 1. So automatically, we can make the assumption that the rest of the 99 1-bit memory after the first one is measured are all also exhibiting the value 1. So this is the concept of determinism. So similarly, if the first one, or even if we want to measure number 26, because all are identical and we exhibit the value 0, so the rest also will exhibit 0. So that's how we can, we understand and we process data and information today. So that is under the concept of determinism. But if you migrate that to the corresponding quantum experiment and the corresponding bit, the classical bit, binary, in the realm of quantum physics, we call it quantum binary digit, or qubit for short. So qubits are more difficult to understand as compared to the classical binary digit or bit, because if we do a similar experiment from what was done just now, and you prepare 100 kind of memory of qubits in the same qubit state, and you start measuring the first one, it does not guarantee you the same values for the rest of the 99 qubit memories. You have to get different measurement for every single one of the 100 in this case. So unlike the traditional classical experiment just now, the corresponding quantum experiment, if you do it with 100 qubit memory storage, you will have different values for each of the memory that you store, these qubits. So that is one of the things that is related to what we talk about ignorance. It is something that inherent in quantum physics. So it may not be treated as something which is disadvantaged, but rather it is useful, because when we make use of this concept of quantum or the qubit, as you can see, the one on the left side is the normal way of digitization. So you have the binary digit 0 and 1, and you cannot have something in between, okay, because it's a black and white logic. Yes, no, 1, 0. But if you migrate that to the corresponding quantum realm, you can have now a quantum bit or qubit, which is a superposition of the value of 0 and 1. So if you try to imagine that, the next slide will show you what it means. Sorry, not this one. Yeah, this one. So this is the concept of the qubit, because the north and the south, okay, on this sphere, the north pole and the south pole, in this case, the north pole is the value 1, and the south pole is the value 0. So the qubit is a superposition of this value 0 and 1. So mapping it onto this sphere, which is called the block sphere, you will have infinite values on the surface of the sphere. So you can have any points that make up the surface of the sphere, and that will also represent one of the values of the qubit. Okay, so it is a superposition state. Now, the quantum advantage of quantum computing in this case is that the architecture is SIMO, single input, multiple output. So it's a so you can actually imagine you can feed in these qubits, and the algorithm to process the information will run simultaneously and in parallel. So instead of the normal way of the paradigm shift here is not, instead of the conventional way of introducing parallel processing, here the qubits themselves will be able to be processed simultaneously, and the output will come out as a result, okay, of the processing, and eventually it will give you the calculated output. Okay, so there are many things that you can do with this quantum computing. Eventually, the thing that is doing this computation is called quantum computers. And in particular, what will Malaysia miss out if we don't jump into this bandwagon? So it will transform, it will impact every aspect of our life, from technology, science, and economy. So this particular slide, if we zoom into science and technology, we have a lot of sub-branches, from quantum chemistry to quantum simulation to quantum algorithms to quantum machine learning and quantum communication. So as you can see, a lot of things will be impacted because there are things, okay, if I just skip back here, quantum algorithms running on the quantum computers using the ability to solve certain types of problem will give you much faster than any classical computer. So that ability, any nation state accessible to such quantum computers will be in command. A lot of things they will be able to do. But of course, when we talk about the quantum computers, just like the knife, you can use the knife to do something good, or you can use the knife to do something bad. Similarly, with the quantum computers, you can do something good to come up with the design, discovery of new drugs, all right, to do a lot of things good for the betterment of humanity. But at the same time, you can also hack into information security systems. Now, the main challenge about quantum computer is that if you use these qubits, for example, qubits may be realized through optics, may be realized through semiconductor kind of approaches. Always the challenge is how long can you preserve a particular qubit before it is, dissipated. It loses its energy. It's not like the 0 and 1 kind of thing. If you put it 0, it will be 0 later on, 1 hour later. But this kind of qubits, they are very vulnerable to being dissipated, disrupted by the environment. So these are the main, this is the main challenge to quantum computing. One, because quantum bits or qubits, they are vulnerable to the exposure to the environment. And then number two, how long can you, the memory, how long can you store qubits in the memory to preserve that information? Now, the next question that we may be asking, how do you realize a qubit? Okay, to realize a qubit, if we refer to the Holy Quran, Luqman verse 20, is translated here. Do you not see that Allah has made subject to you whatever is in the heavens and whatever is in the earth, and amply bestowed upon you his favors, both apparent and unapparent. But of the people is he who disputes about Allah without knowledge or guidance or an enlightening book from him. So from this verse, for example, we are taking just this particular verse. There are many other verses. It shows to us that human beings, whether you're Muslim or non-Muslim, Allah has subjected, for example, nature for mankind to exploit, to serve humanity, to do good. So to realize the qubit, to run these quantum computers or quantum computation, one of the things that we may resort to is optics, geometrical optics. So when we look at optics, light previously has been considered as straight line rays, beam of light. Okay. Eventually, people also get to know about wave optics or physical optics. Light also do have properties of the waves, talking about destructive and constructive interference. And eventually today, the latest is that, as I said earlier, we talk about quantum optics, which is optics. Light exhibit both particle wave duality properties. Okay, so if we take the property of light under the topic of geometrical optics, we are quite familiar of the concept of light being reflected and refracted. Every time we go out, we want to make sure our hair is nice, in order. Look at the mirror, and then that is the property of reflection. We look at the mirror, light is reflected, so that we see ourselves in the mirror, and we make use of the property of reflection. There's another property which is called refraction. But all this, it treats light as a straight traveling beam of light. Now, to realize, to produce this qubit is very simple if you use light. Just like the previous slide, you make use of the concept of reflection. Now, if we look closely at the mirror that we have in our houses or even our offices, the secret for light to be reflected fully, 100% reflection, is that it is fully silver, the silver painted of the light, of the glass. So light will be reflected 100%. Now, if you just make the glass to be not totally reflective, some of the light will be transmitted and some of the light will be reflected. So you can imagine on this slide here, I'm showing the real experiment where if you use a green laser, you shine it into a, let's say, partially transmitting mirror, where some of the light that comes in incidentally will be reflected and some will be transmitted. Okay, so some of it will go through the glass and some of it will be reflected like the mirror. So we have the 0 and 1 superposition state coming from this simple device. So a beam splitter, in actual fact like this, can be the one that can realize the qubit. So something which is not that sophisticated. But of course, when you miniaturize it, you become technologically challenging. So the state of the art, quantum computers leaders, there is a challenge between Google and IBM today, and they are trying to win the race, so-called. But the thing there is that after watching this presentation, anyone accessible to the internet and have a smartphone or even a laptop, you'll be able to access quantum computers via the cloud offered by IBM. So it's no longer a myth. It's nothing like a science fiction kind of thing. It is a real computer, and you can now run a program on these kind of computers. They have several series, and you may easily go to the website there and see how you can access this. So if you want to learn more about quantum physics today, even in the rural schools, as long as you have internet, passionate students and lecturers, teachers, and also computers, you'll be able to run this kind of thing. So if you look at the IBM computers, if you're accessible to the cloud, so the way you do this, you need to put, just like processing data information in the conventional computers, you will need the bits and the logic gates. Okay, so in this case, the equivalent will be the qubits and the quantum logic gates. So in this particular slide, the H in the square there represent Hadamard gate. It's the Hadamard quantum logic gate. Okay, and the 0000 there on the left-hand side, they are qubits. Okay, they are qubits represented so that it will run. Once you only need, for those who are very interested to test this out, you don't need to know programming. You just drag and drop using this kind of symbols, icons. So the 0, those are the qubits, and the H, in this case, the Hadamard quantum logic gate, and then the meter there is your measurement. So once you have a qubit coming into the H, the operator will operate on the qubit, and you get the output and you measure it. Okay, so once you measure it, you get the so-called computation done. So it's not complicated, because this particular, we call this quantum circuit. Although this quantum circuit is so simple, it is a quantum circuit. You just need the Hadamard gate, a qubit, and then the measuring device. And in actual fact, what it represents is this. In real life, you have this half-sievert mirror, as I described earlier. You send in this very weak light, and then you strike the mirror. Half of the time, it will go to detector 1. Half of the time, it will go through the detector 2. So in reality, it is a realization of a quantum random number generator. So this will fall under the truly random number generator classification. So with that kind of thing, when we teach our students, for example, I hope they become clearer about, it's not so complicated in terms of trying to understand quantum physics and trying to relate it to reality. So when we have many more quantum gates and qubits combined and measuring devices along within the quantum circuit, then it builds up your quantum computer to become more complex. And then you can make use of the quantum computation, for example, to realize some part of deep learning, artificial intelligence, okay, machine learning, and vice versa. You can also make use of AI to choose your quantum gates design. So on one hand, you may want to use the quantum computer to execute your machine learning. On the other hand, you can make use of AI to optimize your design of the quantum computers. Okay, so I think that section sort of give you some overview of quantum computing and then quantum advantage. So I'll move now to the second part, which is quantum safe or information security in the quantum physics realm. So let's imagine that I'm here in Malaysia, and then Professor Mahbub is there in Bangladesh, and we want to share a document. So in this case, Prof. Mahbub has sent me a document via email, but he has separated the password to access the document. So on this screen, I'm showing the real password. Okay, let's imagine that this is the real password. So Professor Mahbub sent to his smartphone the password separated from the original document, and I receive it through my tab. Now, if we have eavesdropper in between, so this eavesdropper may be able to access the raw password if we do not put layers of security to ensure that this document will not be accessible to others. So we talk about secure communication. Now, to have this secure communication, we need to scramble the original password, so we resort to encryption. So what happened to the original password now becomes scrambled, something that is intelligible, so-called, and makes it very difficult for an eavesdropper, a third party, to eavesdrop into your communication. So the question now is, how do we encrypt? How to scramble? So we need to have secret keys. So the secret keys here must be identical. Okay, as we look into this slide, we have the key and the padlock, something to symbolize something that you can lock and unlock. But you need to have identical padlock and key at both ends. So in this case, we have two parties communicating, one in Bangladesh, one in Malaysia. Now we need to have this identical padlock and key at both ends. If we don't have the same or identical padlock and key, then once if it's already scrambled or encrypted, the receiving party without the identical key or padlock will not be able to unlock, okay, to read the document that's been sent. So the challenge is how to share the secret keys. So many years ago, so what they did was you have identical keys in one briefcase at one end, and the other end also similar briefcase of identical keys and padlocks, if you like. So every time they communicate, they have to make use of these secret keys and padlocks. But the question now is, can we share the secret keys without involving a third party? So which means we don't want somebody to intervene or play the intermediary role between the one communicating from Bangladesh and the one communicating from Malaysia. So that is the challenge. So that is called quantum safe. Quantum safe, by virtue, we resort to quantum physics. The one that I've described, these 4 slides, they are still very classical or traditional way of protecting your data or your information. So once we start moving to quantum physics, resorting to quantum physics to protect our information, we look again to the concept of bit. So here, traditionally, it is 0 or 1. Okay, but in quantum physics, you allow 0 and 1. So the word or, and. So for classical, conventional way of doing data processing, 0 or 1. But in quantum physics, 0 is allowed to be and 1, superposition. So the abstraction here is to represent quantum bits and also to introduce quantum logic gates, just like the quantum advantage of quantum computing. But in this case, we are using it for securing information under the topic we call quantum safe. So this couple of slides following here is just showing how I was leading a team of multidisciplinary background, mathematicians, computer scientists, electrical communication engineers, physicists, way back from 2005 to 2011. So we made use of dark fiber that runs from one end in Bukit Jalil, which is Mimos Berhad, right into the campus of the International Islamic University Malaysia, about 45 kilometers away. Okay, so you can imagine we are sending quantum objects in the form of weak single photon signals of light right from Bukit Jalil, 45 kilometers to IIUM many years ago. And at one point, this dark fiber is running in parallel with the LRT. So Dr. Nadir may have experienced that, taking right on LRT. So this optical fiber in this particular case along this route is the one section is actually under the light transit. And this slide showed how the team built our indigenous homegrown quantum key distribution boxes. Followed by testing and measurement in our labs. And then we also built the ones I showed you earlier. This is for the fiber base, optical fiber base. And we also talk about free space, wireless communication. Alice and Bob, these are traditional characters. We talk about parties communicating. So this one is the Alice side, Alice box, Alice system using telescopes and lasers. And Bob side, Bob system. So for the free space, what we did is about 2 kilometers away. We put it in the MIMOS up a few floors, so that's the third floor, and then the other end is Cybersecurity Malaysia 7th floor. The distance between them is 2 kilometers. So this one particularly is not running on the optical fiber right there. It is running on the free space, okay, line of sight. Okay, so this is the beam when we try to synchronize the channel between Alice and Bob on the rooftop and the building. So this is also giving from another angle, from MIMOS angle, looking into the cybersecurity site there. And then this is apart from the synchronization, we have the quantum channel. This is where we send in optical pulses as a line of sight, free space communication. So we built a quantum network with our quantum boxes of Alice and Bob. The green full line are representing the optical fibers, and then the dashed line is the one which is line of sight, free space. So this is what we call the prototype that we run under a metropolitan kind of environment. And alhamdulillah, we managed to demonstrate the first quantum key distribution network in ASEAN. That was 2010, 2011. So if we look into the magazine, The Economist Technology Quarterly, you see that Malaysia is among the top there, even within China, United States, Japan, Britain. Malaysia a little bit higher than South Korea then, reported in March 2017. And then a little bit lower, Malaysia there, under quantum key distribution is under China, United States, Japan, Europe, South Korea. So that was the achievement at that point of time, because we wanted to, the reason why we embarked on this was in the event that we have nation states accessible to quantum computers, then the nation should have some kind of defense in the form of quantum key distribution to protect our critical national information infrastructure. Okay, so the last part here for my presentation this morning is the Kibble Balance. Because how is it relevant, quantum physics, to our daily life? So in Malaysia, we have two relevant metrology acts. Metrology is a discipline of measurement. Okay, so the first act that is relevant to metrology here, it is like an umbrella act for all measurement legislation in Malaysia to enable an individual or organization to have the means to make accurate and traceable measurements. So that is Act 675. And then there's also Act 71. This is under regulation. So this enforcement of this act is governed by a certain ministry, and then through a selected company to perform the function of inspector of weights and measures, such as verification, stamping, okay, except for enforcement duties. So it's more like regulation. Now, what does the Quran say about measurements? So in the Quran, one of the verses, it says here in translation, and give full measure when you measure, and weigh with a balance that is straight, that is good, advantageous, and better in the end. So there are several other verses, different parts of the Quran, for example, Surah Ashura 177, 182. In this case, the Prophet Shu'aib alayhi salam was telling his people not to do injustices with respect to measurement and weight. Similarly, for Surah Al-Mutaffifin verses 1 to 4, this is relevant when Allah also reprimanded the companions of the Prophet Muhammad sallallahu alaihi wasallam. So it's not just for the previous prophet, even our own prophets and the companions were also reprimanded for us to pay particular attention to measures and weights. So if you look into this couple of slides, what I'm trying to drive home is that due measure is a big deal. So we need to be just. We have the act, legal standpoint, we have the reminders coming from the Holy Quran. It's a big deal. Now, sometimes we get messed up with the definition of weight and mass. Okay, the weight of a person on Earth is 560 Newton. Nobody talk about what is your weight in terms of Newton. But if we go to the hospital and so on, what is your weight will be given in terms of kilogram. But strictly speaking, weight, which is a force, which is a vector, it means that you have to measure in terms of Newton, okay, the unit for force. So the same person, if goes onto the surface of the moon, will have a weight of 90 Newton compared to the 560 Newton on the surface of the Earth, because of the gravitational pull on the moon is lesser compared to the gravitational pull on the Earth. So weight is dependent on the gravity. But the composition of the content in your body, which is represented by the concept of mass, is measured in terms of kilogram. Okay? So this particular person, whether she is on the Earth's surface or the surface of the moon, the mass is constant, 56 kilogram, SI unit. So it doesn't change, not affected by the gravitational pull. Right, so 20th May every year is celebrated as the World Metrology Day. So on the May 20th, 2019, the definition of the kilogram has changed. So what used to be every country will send representative to Paris maybe every 2-3 years, to compare the 1 kilogram that they have in that country to the standard that is preserved in Paris. For example, on the right side of the slide is the cast in platinum. It is kept in the triple lock vault, and you compare this with your own 1 kilogram. So come 20th May 2019, the definition has now been redefined. So countries do not need to go to Paris anymore, because now they make use of quantum physics to define kilogram. And how did they manage to do that? Is because they treated the Planck constant, that H in the screen now, to be a constant of nature. Right? So the E equals to H nu here, the frequency, is the one related to the earlier slides I was showing you involving quantum fluctuations. Okay, so the discreteness of the energy level of these quantum objects is now being made use to redefine the kilogram, which is the SI unit, for mass. So you can actually realize this using Lego components. So in this classroom setting, you can ask your final year project students to realize the experiment within an uncertainty of only 1% to get that measure of the Planck constant. So the concept is, although the Kibble balance looks like the equal arm balance, but the equal arm balance is passive. But on the other hand, the Kibble balance is active. So what I'm trying to say here is, this is how the descriptive diagram of the Kibble balance, it will run into two modes. One is called the velocity mode, where you will measure the voltage, and the other one, the same device, but now it will be used to in the force mode, where the current is measured. So the one on the right hand side most is where you have the force mode. You put in the mass that you want to measure, and you'll be able to compare the equations that you come from the first mode and the second mode. Then there's a relationship between mass and the Planck constant there on the screen. So the real Kibble balance in the National Institute of different countries, like the one I'm sharing here, this is in America. So this is the Kibble balance in America and in NIST. So several countries also developed. As far as Muslim countries, I think it's Turkey. Even Malaysia, I think, do not have it. We have different other countries, of course, Britain, Switzerland, I think. Yeah, many countries now develop this Kibble balance. So it's not really that complicated, because even at the classroom setting, you can do the one using Lego components. And this one, of course, will have demand more money to make it very accurate. So, in conclusion, let me see, what time is it now? Okay, just nice. In conclusion, quantum advantage is a reality. So, in other words, quantum computing is already there. Our students can now access quantum computers via the cloud, thanks to IBM. Quantum safe is now more accessible. And when I say now more accessible, because a company in Canada is called Quantropy. So there's a paper I can zoom in. If you can zoom, yeah, okay. You can Google this, entropy, the concept of keep their solution, quantum entropy expansion and propagation overview. So If you look into that solution, it is different from the quantum key distribution solution that I talked about. Because if you hear closely what I said earlier, the challenge of sending weak pulses across optical fibers and over free line of sight, free space line of sight kind of thing, wired and wireless, is very challenging. But this particular company have patented several solutions. They can make a kind of marriage, a hybrid solution, combining quantum safe concept using quantum physics as well as traditional infrastructure, which means they are offering quantum safe. At the same time, you do not need to change your infrastructure, so which is very good, because otherwise it would mean a lot of money to come up with the devices and also perhaps to talk about dark fibers and those things. So now, when I say quantum safe is now more accessible, you can have almost very secure unconditional security under existing climate infrastructure. And finally, quantum metrology is becoming more relevant. When I talk about the Kibble Balance, is under the realm, the discipline of what we call quantum metrology. There are many other things, interesting things about quantum metrology, but I'm just taking one which is relevant to kilogram, which is, I hope is easy to understand. And yeah, I hope these three sub topics give you an overall picture in terms of quantum physics and quantum information processing and relevancy in our daily life, from quantum advantage, quantum computing, into quantum safe to secure our information, as well as measurements in terms of quantum metrology. So I end up with my presentation. Back to maybe Dr. Nadir or Madam Nusrat. Thank you.
Thank you, Professor Dr. Muhammad Ijja Wahidin, for your valuable insights on quantum computing. At this point of session, now I'd like to request Dr. Nadil bin Ali sir, a proud alumni of University Saint Islam Malaysia, to conduct a question answer session with our keynote speaker.
Thank you, sir. Thank you for your valuable time, sir. Again, thank you from me and from Daffodil International University for your nice presentation. And we have learned a lot from you today. It's true, quantum computing changing industries and transforming the world. It's true. It's my pleasure to inform you that I am proud alumni of USIM. And just recently, I have completed my degree from your university. So it's again true. Quantum computing is very new topic, especially for me. We know just classical computer processing data in the form of 0 and 1. We have learned, but the quantum computer store and process the data in the form of qubit. So we know and we learn today the quantum computer are useful for the simulation, drug development, and this is the weather forecasting, traffic optimization, and Google already used the Google search and artificial intelligence, and the machine learning, the quantum computing already are used. So and I don't know, this is not in the is open for public. Maybe
it is open to the public as far as the IBM is concerned.
Yeah, it's a very low price. Yes, sir.
You don't have to buy.
So is the issue, even it's not possible to buy. But sir, now if you allow, we'd like to discuss on the question answer, as I have got some question from different student and teacher. Just one question I have received. You see, the what hurdles do researchers face in developing a quantum computer? What hurdles researchers face?
Okay. As I thank you for the question. The first hurdle, which is most important, is your passion, your stamina, your thirst for knowledge. Okay, because it's quite normal in our countries, whether it's Malaysia, Bangladesh, even advanced countries, Japan, US, UK. If you meet people in the streets, when you talk about you are doing mathematics or physics, they will say, "Wow, it's so difficult." Okay, so so you can imagine if it is in United States and even in Europe, the people on the street saying that is not really uncommon to have that in our countries. So our first hurdle, the obstacle, is to have a mindset change. Okay, that is very important. Number two is we talk about critical mass. Okay, in Malaysia, in Bangladesh, you don't need everybody. Okay, to know quantum physics. We need that critical mass that will help to jumpstart and fast track the development and grow the relevant industry in our countries. So
Okay, so yeah,
the technology part, as I said earlier in the slides, of course, if you realize the qubit, realizing the qubit is one thing, but to sustain the qubit is another thing. Because if you imagine you use light to create a qubit, and have how do you freeze light to maintain it as your memory, quantum memory? That is a real challenge.
yeah. So one question I have got from one of our student: which companies are developing quantum computers? Maybe as I know that I don't know the answer. Is it maybe Microsoft, IBM, Google, or Honeywell,
Yeah.
something like that? This company are developing that. Yeah, I
So
think that answer.
if you look into my slides, I think you may have recorded it. So the first slide, the first few slides, I put in the logos of the companies involved. So you may have people coming from Korea also participating, from Japan. America, as I said, is Google. You have IBM, the quantum software part, Microsoft, and several others.
And so the next question is very relevant. One of our teacher, just question is how we can integrate quantum computing in our curriculum.
I lost
In our
your.
in
Can
your
you
country,
repeat?
what
Because
is
I
the
think there's
practice
some
and how
disturbance
we
just
can
now.
integrate? Yeah. Have you got my question, sir?
And I think I still there's
How we can,
some
how we can integrate quantum computing in our curriculum?
there's some breaking.
You're getting my, how we can integrate quantum computing in our curriculum.
Sorry, I can't.
Sir, can you
I
hear
can't
me
make out what
now?
the question
Okay,
is.
okay. Next question is you
Somehow
see
this
just
this interval is the
okay.
message is breaking out.
Okay, last question is how do quantum computing and quantum mechanics relate? You get my question?
Uh, Prof, like Dr. Nadir is asking that how quantum computing and
I still can't make it. Maybe your colleague, Dr. Imran or Madam Nusrat.
Sir,
Do you hear me?
my last question was,
I can't make out the question. Sorry.
my last question was how we can integrate quantum computing in our curriculum. Can you hear me, sir?
নুসরত ম্যাডাম আপনি বলেন দেন নুসরত
Sir, do you hear me?
I
Professor
still,
Rijai, do you hear me? No, I think so. There is a
Suddenly,
problem.
the channel is not very clear.
But
Oh,
we are getting you clear, sir.
yes, we are
Maybe
getting clear.
uh, we are getting very clear that this was the last question. So if not,
You can try to repeat if you.
can you hear me now, sir?
The voice is breaking up. I can make out.
Oh yeah, but that means maybe this is connection problem, maybe something like that or other issue. But we are clear here, you, sir.
So, should I conclude?
Okay,
Or
there's a.
get the
Okay,
question
I
from the
can see
audience?
now.
Okay, okay. Just
There's typing there somewhere. How
okay.
can
That's
we integrate?
yes, yes. How we can integrate quantum computing in our curriculum?
Okay,
Yes,
I think what you're asking is somebody is asking about the integration, right? The integration.
yes, yes.
Okay, so uh, one step which is very important here towards the end of my talk just now, I was talking about this.
Okay.
Okay,
So okay,
okay.
no problem.
Let me
Okay, no
try to
problem, sir.
answer the first
We
question
we
that
would
has
like to
been typed
integrate.
just now. If we follow this quantropy uh, solution, they propose that it is using parts of the quantum computer, making use of what they call permutation quantum gates, and they are able to put it within the existing structure. But in this case, it's not meant as a quantum computer. It is using parts of the concept of quantum computation, particularly permutation quantum gates, to protect our information. So you can put this kind of equipment within our existing telco communication, optical fiber, and so on. So that means you don't need to have a lot of investment of trying to make use of this quantum technology to protect your information and data. So that's number one. Number two, with the existing of quantum computers accessible to the cloud offered by IBM and several marvelous, interesting quantum simulators, you can Google the internet. We can explain a lot using infographic and simulators to our students now. The concept of quantum entanglement, the concept of some other, weird concepts in quantum physics, Heisenberg uncertainty, and so on. So, for countries like us, where we don't have the luxury of a lot of money to build expensive experiments, we have to resort to this kind of things. That means the availability of, for example, the IBM computers via the cloud, and also the simulators, so that our students and our teachers, our staff, academic staff will be able to understand better the concept of quantum entanglement, for example. But if we have the resources, we may be selective to implement experiments that to realize quantum entanglement in certain labs within certain universities. Okay, so some of these may not really require that much money, but then again, it means to be focused and selective. Okay,
Okay, sir. Thank you, sir. We would like to
I
integrate
hope that answered
quantum.
the questions.
We would like to integrate the quantum computing in our university. Next time, definitely we will communicate with you for expert opinion. And you are welcome to visit our
It's
physically
okay.
Daffodil International University.
At
That's
least
all.
he can see that I put his image in the slide
Yeah, yeah.
for
That's all from my
Professor
side.
Mahmood unable to join us
Yeah,
today.
yeah, yeah. That's all from my side. Now over to Nushat Madam, please. Thank you, sir, for your question answer and joining here. Thank you. Assalamu alaikum from my side.
Thanks, Dr. Nadir bin Ali, sir, for your kind participation. Our Provisy sir deeply apologized because he cannot join due to some technical problem. Now I would like to request our department head, Dr. Imran Mahmood sir, for vote of thanks and concluding remarks.
Thank you, ma'am. Okay, thank you, Prof. Thank you very much that you joined us. And like this is also first time for me to understand something about computing, quantum computing, and I found it very much interesting. Recently, we introduced major in data science, major in robotics in our department of software engineering, major in cyber security. Maybe I think that this quantum security I can integrate in our curriculum, and when we will do that, we need your consultation, we need your support, and of course that me, Dr. Nadir bin Ali, we finished PhD from Malaysia. Miss Nusrat Jahan, she is also doing PhD in UNIMA, University Malaysia Perlis. So we all are educated from Malaysia, and we feel that Malaysia is like our friend, and whatever we learn from there and we try to implement in our country. That's why we actually invited you to enlighten us about quantum computing. Our Vice Chancellor deeply apologized. He could not join due to technical reason. Google Meet and other technology might help. Anyway, thank you very much again. When you are when you will be free, please visit us in Bangladesh in our university. Okay, Prof. Thank you very much. Assalamu alaikum. Thank you.
Thank you, sir. Assalamu alaikum, sir.
Assalamualaikum warahmatullahi wabarakatuh.